design is one that's simply going to suck in the debris from the ground. Okay, there's going to be an additional system as well, which is just going to be closely located around the base, which is our intake debris, which is going to be very kind of fine particulate matter. But this is kind of like debris that's been like soil and rock and whatever, that's kind of been left scattered on the ground. Okay, so this one I'm just going to create a new empty flow and then label this. Let's call it PF source dust and debris. And this particular icon, I need to make sure that this icon type is set to circle. So if we have a look in our viewport, if I just bring up actually top viewport, and then let's grab the dust and debris one. There we go. It's obviously located at the origin at the moment. Actually, I think I'm going to hide all the barn stuff for the moment while we deal with our new system, which has nothing to do with the actual barn itself. So so what I want to do, I think I'll reorient it so it's pointing the right way first before I actually position it at the base of our funnel, because obviously as the funnel is travelling across, we obviously need to have the particles being drawn out, and then if they're going to check to see if they're going to be moved or affected by the space warps. So that orientated the right way. What I want to do now is let's make sure I grab that, align that with the one of the space warps down here. Now, one thing that's obviously happened is the fact that when the particle flow source dust and debris has obviously been created in here, it's obviously positioned it right on the Z height of 0. So the problem is the fact that what I need to do is I need to lift this guy off the ground. Now, the reason I need to do that is because the deflector also is located at Z height of 0. If I didn't lift this guy off the ground, chances are that I would have some particle positioning issues, i.e. the particles will be born on this icon itself, which, like I say, is positioned exactly the same place as this deflector. So there's a high possibility that the particles will get stuck, or some of them will get stuck underneath the deflector, and will be fighting for space when they're actually born, so it will cause some issues. So what I'm going to do is I'm just going to offset that. Actually, I think that'll do, actually, just offset it by a value of like 0.18. And then I'm going to link this guy to the funnel. Okay, so that's that sorted out. So what I need to do now is have this particle flow source icon as quite a large diameter. I'm actually going to increase the logo size as well, so we can kind of see it in the viewport. I'm going to stick that to about there. And the diameter itself, I'm actually going to increase that all the way up to about 800. Okay, so if I look in the top viewport, let's just see exactly how big that is. So it's quite a large area. Okay, what we need to do now is scatter particles over this icon, and then get them to be dragged into the funnel if they are affected by the vortex. So I'm going to go back into particle flow, and let's start setting up the system itself. So what I want to do is, as I mentioned previously, towards the beginning of the tutorial, we want to have this initial kind of trail already established. So I need to add in a birth event that's got a negative value in the emit start. So I'm going to set that to -100, and the emit stop is going to be set to 200. Now, just in case you decide to extend the length of the animation, what I'm going to do is I'm actually going to kill the amount, set amount, and I'm actually going to dial in a rate. So for that, I'm going to actually set a rate in about 6250. So that gives us a total of about 75,000 particles in total. I'm going to wire the output of this guy into the input of this one. So obviously, because we won't be able to see anything in the viewport yet, because we haven't told the system where to have the particles born yet, so I'm going to stick in a position, actually no, it's a position icon I need to drop in there. So get rid of you, and I'm going to stick you between there and there. So that will say, okay, there's this amount of particles being born. Now I think what I'll do, actually I don't think I've actually got enough in there, so I think I'm actually going to stick some more in here. However, I don't obviously want to see all these guys in the viewport, so I'm going to dial this viewport quantity multiplier down to 1. So I think I'm going to increase this rate value up to, let's say, I'm going to do it by a factor of 2, so I'm going to, let's say, 12,500. So that will go up to just over 150,000 particles in total. So because I've obviously got this viewport quantity multiplier set to 1, we're obviously seeing a fraction of them in the viewport here, so obviously got this lead back like I mentioned earlier. Okay, so with that set up, what I basically need to do now is to tell the system that after a certain amount of time these guys are going to get deleted. So I'm just going to drop in a delete operator in there, just get rid of that ticks, and I'm going to set it to biparticle age with a lifespan of 4 and a variation of 2. So now obviously if you decide to check in the viewport, then obviously you won't see anything, quite simply because we've got the display operator taken out now, so no need to worry about that. Okay, so next thing we need to introduce is the Vortex dust in there to affect the motion of the particles, to try and obviously bring them in within the certain boundary that it's obviously got. So if they start moving, like I say, then they start being piped to the next event and made renderable and start swirling around the vortex. So let's drop in the vortex dust in there, which is this guy here, and I think we can just pretty much leave that as is. So the next thing we need to do is just check for speed. So it's going to be this speed test here. Obviously you need to position that underneath the vortex dust. Okay, and this speed test, I think same deal as previously. We'll actually set that to actually I think we'll break this up a little bit. I think we'll actually say, okay, we'll have a test value of, let's say, 10 and a variation of 5, just so that it kind of breaks it up a little bit more. We don't get like a kind of linear line around here when they suddenly start moving. It kind of breaks up a little bit, it kind of fragments it up a touch. So in essence it's giving the impression that some are heavier than others. Okay, so we might have the kind of like a bit more kind of fragmentation in the way the particles are sucked into the vortex. I'm just going to rename this guy as well, actually, at this stage, I think. So I'm just going to rename that. Let's call it debris placement. So let's set up some of the properties in the system when it's actually airborne. Now this particular one, what I think we'll do is we'll use the same properties that are actually got in this impacts one once it kind of, because obviously this is obviously impacting with soil, so obviously we want like a similar size in here. So therefore what we can do is we can simply just copy this operator here, okay, and then let's instance it across to the canvas to create a new event, and we'll label this one, let's call that debris airborne intake. Okay, I'm going to wire the output of this guy into the input of this one. Okay, and I think what we can also do is let's take in the scale from this guy as well. So I'm going to copy that and I'm going to instance that in there as well. I think what we'll also do is we'll also take some additional properties in here as well. I think we'll also take the spin from in here as well. The speed, because previously we obviously had it as inherit previous, this particular time we actually need the particles to kind of lift off the ground a touch before they actually start being picked up properly by the vortex. So what I think we'll actually do is instead of obviously having this speed and variation, which is obviously the impact, I think what we'll do is we'll set it to because we've obviously got the icon pointing in this vertical direction. So just switch back to the front viewport. We've got this icon pointing in this direction here. We can actually use that to lift them off the ground. So we've got it set to a long icon arrow. So I'll set the speed in this guy to lift them off the ground so they don't immediately interact with the deflector. I'm going to set that to speed value of 10 with a variation of 10 as well, and I'll also set the divergence to a value of 10 as well, I think. Okay, next thing we need to introduce is the vortex dust as before. So I can simply just copy this guy from this one, because again, same kind of properties, same kind of material that we're dealing with. So let's copy that, and I'm going to instance that across to that guy. And then the next thing I need to do is to copy the gravity and instance that one across as well. Okay, this particular guy, I think for the color, because like I say, we are dealing with the same material, we can simply just use this display operator in here to copy that and instance that across to this thing, and then get rid of that. Actually, just remember we haven't actually labeled this guy, so let's call that let's label that impact debris airborne. Okay, so that's the initial properties of our airborne debris that's originally situated on the ground. When it actually hits the deck, so obviously we've got gravity in here, we also need to make sure we've got this copied, and let's instance that across to there so we can test for ground collisions. This particular one, when it actually hits the deck, I want to spawn some additional particles. Now what I want to do, because I'm dealing with spawn tests, I don't want to accidentally spawn some geometry in here, because obviously we're starting at minus 100, so we've got to be careful. So what I want to do is I want to turn this guy off at this stage. Okay, so first thing I need to do is drag out the spawn to the canvas to create another event, and this one I'm actually going to rename it and call it debris impacts, I think. So debris impacts. Okay, so I can wire the output of this collision into this guy here, and now I can also wire the output of this guy in there as well. So when this airborne impact debris, which has obviously been generated from the logs, or the shards of building hitting the deck, they can obviously break up as well. So I'm just going to pull that across there so we sort the wiring issue out. Okay, and in this spawn test, what I want to do is I need to tell the system to just pull that across there. I'm just going to maximize that, select that guy. I want to tell it to delete the original particle, because obviously we're going to fragment that particle up. We want to have quite a large offspring. That's he's going to set an offspring of 10 and a 100% variation, so we're getting a lot of kind of variation in the distribution from the impact. Okay, we don't want as much as we don't want the full inherited strength when it actually hits the deck, so therefore it kind of, if the particle hits the deck like that, we can basically just have a small kind of distribution. Obviously bear in mind that the collision is also dealt with the deflector. The deflector's got basically a low bounce in there anyway, so we don't want this to go too low. So for the inherited percentage, I'm going to drop that down to 50 with a variation of 20, and quite a wide divergence, let's say to 45 degrees or something like that. As we're basically deleting the original parent and we're dealing with a fair amount of offspring, I actually want to set the scale value down to 50% with a variation of 50 as well. Now obviously that 50% is obviously going to be well, 50% times 10 is going to be more than 100%. So in essence, we're kind of simulating the particle hitting the deck, or hitting the grass and hitting the dirt, and it's not only kicking up, it's not only fragmenting itself, but it's also kicking up ground debris as well from the impact. So that's the kind of thing that we're trying to simulate here. Because obviously we need to make sure that this system is also going to be, this event, sorry, is going to be picking up well, it's going to be picked up by the vortex as well, so we need to introduce the vortex dust in here as well. So what I'm going to do is I'm just going to copy this event from up here, sorry, copy this operator from up here, and I'm actually going to paste it in there. I'm not going to instance it, because I'm actually going to drop the influence value in here down to 500. Okay, we also need to introduce the gravity, which is obviously this guy in here as well, so that needs to come back in and be instanced across to there. Alright, and we also need to double check for speed as well, same kind of principles that we had previously. If the speed test is actually less than a certain value, we can actually make the entire make the particle stationary by piping it to the next event. This basically, the reason we've been doing this overall is quite simply to basically save on calculation times with the collision test, so it makes it easier for the system to calculate it at render time. So what I can do is just grab one of these guys from back here, so it's going to be one of these from, like, for example, the roof tiles collision, so we can just copy that and we can just simply, oh, there we go, instance that across to here. And the next thing I want to do is I just want to make sure that none of these guys pass through the deck again, so I'm going to copy this collision test and then instance that in there as well. Okay, so that's this debris impacts sorted out. Same principle as before, I want to make sure that I'm still dealing with the same color, so I'm going to copy that, I'm going to instance that across to there. I mean, what you could do is you could actually set this display operator up in the root event up here, which is apply it to the entire system, well, this entire lot here. Same deal up here. If you wanted to have it for this system, you could basically just copy and instance it across to here. Actually, I don't think we need to see this ticks operator anymore, to be honest, so I'll just get rid of that. Okay, so once the debris has obviously been checked for speed, once it's below a certain value, so obviously once it's slowed down to 0, again, same principle as before, I want to kill the speed and kill the rotation from this, well, kill the spin from this guy up here. So I can actually grab all that stuff from over here. So I've got the spin is set to 0, speed is set to 0, so I can simply just grab hold of those guys, copy that, and then instance it across. And then this thing I'm going to rename, let's call it debris, speed and spin. Actually, was it speed and spin or spin and speed? What do we call it? It was kill, speed and rotation, I think it was. Okay, so debris, kill, speed and rotation. Actually, technically it's spin, but never mind, a bit late in the day for that now. Okay, so these two guys have obviously had their spin and speed taken off, but obviously we need to again check to see whether or not the vortex is going to pick it up again, so we need to grab this vortex dust and instance that across to there, and also we need to check for collisions. just in case the vortex nudges them beneath this deflector. And we also need to check for to see whether or not they start moving again. So to do that, it's simply a case of just dropping in another speed test, same kind of deal as before. We can just grab this guy from here and drop that in there. Actually, I think we'll have a slightly higher value in here. I think we'll actually set that up to 2. So I've not instanced that across, by the way, just so you know. So if it's greater than value of 2, then we'll start making it airborne again. Okay, so bear in mind that the speed test that we grabbed from over here was obviously within the kill speed and rotation event over here, so it's corresponding to this one over here. And then the debris impacts speed test was basically to check to see if it was less than the test value. So this less than test value with value 2 in here, this one, and greater than test value of 2 in this one here. So the one thing left to do is to simply just wire the output of this guy into there. Okay, so that's the kill speed and rotation sorted out. So the last thing I need to do within this particular system is simply actually no, I need to copy this guy and replace this display operator, don't I? So I need to copy that and then instance that across to there. So the last thing, like I say, I need to do is to should the particles start moving again, need to pipe them back into this well, I need to pipe them into this next event down here and then pipe them back into this guy here if they stop, if they slow down again. So to do that, what I can simply do is just pull in the properties from in here. So I'm just going to hold down shift and just instance that across. We don't need the spawn operator in this time, so we've simply got the vortex dust as the force and the gravity in there as well. We've also got the collision and the speed test. So the speed test, which is obviously checking for see if it's actually slowed down. If it has slowed down again, back it goes into the kill speed and rotation. Obviously we are killing speed and rotation, so we need to add a little bit of rotation in there as well. So what we need to do is just drop in, let's say, I think we'll drop in the same kind of value as we had in previously. So I'm just going to copy that guy and then instance it across to here. So that can basically go, I think we'll leave that where it was, to be honest. Let's just put it, actually we'll put it back down there. Okay, and then wire the output of this speed test, I'm just going to drop that side so it doesn't get confusing, into the input of this, well, which is in essence the debris impacts 01. So I'm going to rename this, let's call that debris airborne again. So that's pretty much what it is. Okay, so that's the system now set up for the dust and debris. There is one more that we need to do, and that is simply a case of the intake debris, which is this kind of fine matter around the base of the cone, the actual impact point of the funnel on the ground. So at this particular point I'm going to save this scene out, and I think I'll also, just for safety, set these systems as well for motion blur and the shadows. Actually, you know what, I think I'll actually leave the shadows on for this guy, because these particles are slightly bigger, and also there's going to be a fair amount of them, so they obviously need to interact with each other. So therefore I'm just going to set image motion blur on for both of these. Okay, so that's the main got for the particles set up. So we just need to do one last system, which is going to be 3 individual birth events, one for the central core, one for the middle core, and one for the outer core. Quite straightforward. Again, it's just one kind of particle flow source icon, which we can basically just use this guy here and well, just copy it across and then set up its individual properties as well. So let's just, before we do that, I'm just going to save it again for safety, and then I'm just going to go to the camera viewport and we'll have a look at our dust and debris system here. So I'm just going to turn this guy on, and it's going to sit here for a second while it basically pulls in the info, and then I can simply just, well, I'll make sure real time's turned off. I'm just going to play through this, and this will go through relatively slowly. You can see this dust and debris, which is main kind of like heavier debris being churned around the base here, picked up and then kind of dumped back down again as the vortex boundary passes these areas around here. So you can see this kind of nice trail that's been dragged up and then dumped down here. So if I, when we get to frame 200, if I just go to the top viewport, you can see this nice kind of inlet pulls that I mentioned previously. So we've got this nice kind of defined trail of our vortex. Okay, so this is the kind of thing we wanted to try and simulate. So you can see the actual boundary of our space warp here. So if you actually wanted to extend this out any further, what you could do is just well, you could extend it out to about the boundary of here. But if you wanted any more, then I would say, you know, you'd have to extend the size of the particle flow source icon outwards. Okay, so I'm just going to skip back to frame 0 now and turn that particular system off, because we don't need to deal with that at this particular time.